All right, everybody. So today we are talking about rational equations. We'll talk about inequalities tomorrow, but today we're just going to be focusing on rational equations. So day one of lesson 4.5. All right, so as a warm-up, we've got just some adding and subtracting of fractions. It's maybe been a little while since you've seen problems like this. But just a reminder, when we want to add or subtract fractions, we need to have common denominators. So for A, the denominators are already common. We already have a 9 for both denominators. So this one's going to simplify to just 5 ninths. So 7 minus 2 gives you the 5 on top, 5 ninths. For B, though, 3 halves and 5 sixths, those do not have common denominators. So we want to convert the 3 halves so that it also has a denominator of 6. So we're going to do that by multiplying top and bottom by 3. That changes our problem into 9 over 6 plus 5 over 6, which would give us a total of 14 sixths, which would reduce then to 7 thirds. Then for our last round, we've got 7 eighths minus 1 third. 8 and 3, we want to think about what is the least common denominator between 8 and 3. So that's going to be 24. So we want to get our denominators in terms of 24. First fraction, multiply top and bottom by 3. Second fraction, multiply top and bottom by 8. So our new problem becomes 21 24ths minus 8 24ths for a final answer of 13 24ths. So when we solve rational equations, that same concept of getting common denominators before adding or subtracting is going to come into play. So here's just the basic steps in order to solve the majority of rational equations. First, we're going to figure out what the least common denominator would be between each of our fractions. Then we're going to convert each term into a fraction so that it has that least common denominator. Once all your fractions have the same denominator, we're just going to eliminate all of them. Next up, you're going to solve for your variable. And just like with our radical equations, we want to make sure that we check our solutions. So by plugging in our answers, that's going to make sure that we account for any solutions that might be extraneous. All right, here is our first problem. We've got 12 over t plus t minus 8 equal to 0. So we only have one fraction here. It's the 12 over t. The quickest way to get rid of that denominator is to multiply everything through by t. Here's going to be the result after multiplying each of your terms by t. So the 12 over t becomes just 12. That t becomes a t squared, and the minus 8 becomes a minus 8t. Next up, we're going to rearrange our equation. So we've got a quadratic that's in the correct format of your squared term, then your regular term, then your constant equal to 0. And next, we're going to factor. So because we've got a quadratic, we can factor that into a t minus 6 times a t minus 2, because what we're trying to figure out is what two numbers multiply to 12 and add to negative 8 at the same time. So those two numbers would be negative 6 and negative 2. That would give us our solutions then of t equals positive 6 and t equals positive 2. Plugging back into our original equation to check to make sure both of our solutions work, they would both work. So t equals 6 and t equals 2 are the two solutions for this rational equation. All right, here's the next one. First thing we're going to look at is each denominator. We've got a 6m, 3m, and a 4m. So there they are listed out, and we want to think what would be the least common denominator between all three of those denominators. So looking at the 6, 3, and 4, the least number that 6, 3, and 4 would all divide would be the number 12, because 6, 3, and 4 all divide 12. So we got to have the 12 in there. And since each denominator had an m, we also need to include that m. So 12m is our least common denominator. Our next step, we want to convert each fraction to have that least common denominator of 12m. Our first fraction had a denominator of 6m, so we need to multiply top and bottom by 2. Our second denominator was a 3m, so we need to multiply top and bottom by 4. And then our last fraction had a denominator of 4m, so we need to multiply top and bottom by 3. Our next step is to simplify. So you'll notice that all of our denominators are now a 12m. And the tops we just got by simplifying what we had written in the previous step and multiplying those tops by whatever was missing in the denominator. So the 2m minus 9, everything multiplied by 4, we're just distributing that 4 in. That becomes an 8m minus 36. And for the last fraction, distributing the 3 in, we get 9m plus 15. Our next step, we are just going to eliminate those denominators. So they are all going to completely cancel. Really what we're doing is dividing through by, or multiplying through by that 12m. So because each of our fractions are being divided by 12m, we're just really multiplying through by that 12m to eliminate them. And we're just left with the tops. All right, so here's that previous step. And we are going to just continue to solve for m, and then we'll check our solution at the end. Combining like terms on the left, we get 8m minus 34 equal to 9m plus 15. And then we're just going to continue to solve for m by getting m by itself. So we have got a solution of m equals negative 49. When we plug that back into our original equation, it does check out, it will work. So m equals negative 49 is our answer. All right, here's the next one. This one's going to be a little more complex. If we look at the denominators, we've got a y minus 3, a y plus 3, and then a y squared minus 9. What I'm going to do to figure out what the LCD or least common denominator is to factor that y squared minus 9. It's difference of two squares, so it'll factor into a y minus 3 and a y plus 3. And you might notice that each of those show up in our other two fractions. Here's the y minus 3, here's the y plus 3. So our least common denominator is going to be a y minus 3 and a y plus 3. Next step is to convert our fractions and to make them have that LCD. The first fraction had a y minus 3, but it was missing the y plus 3. So we're going to multiply top and bottom by that. Our second fraction was missing the y minus 3. So we're going to multiply top and bottom by y minus 3. Our last fraction, if we just look at our y squared minus 9 as factored form, that one already had the y minus 3 and y plus 3. So we're going to pretty much leave it as is. Here's our simplification. Now, I kept the 5y minus 15 in parentheses in this step. And the reason I did that is because after we eliminate the denominators, we want to make sure that that minus that's separating our fractions distributes to everything in that numerator. So here's what it looks like, just eliminating our denominators. We've just got the tops left. All right, then we are just going to solve for y and check our solution. Distributing the negative into the parentheses, here's the result. Combining our like terms and solving for y, we get y equals positive 1. Checking your solution by plugging positive 1 back in for all the y's in your original equation, it checks out, and so that is our solution. All right, here's the last one for today. If I look at each denominator, I've got two denominators with an x plus 2. And then this fraction in the middle has a denominator with just a single x. So the factors of our denominators are an x, that single x, and an x plus 2. And we're going to think about that as one factor together, the x plus the 2. So our least common denominator needs to have that single factor of the x as well as the x plus 2. We're going to convert each fraction so that it has that least common denominator. Our first fraction had the x plus 2, but it was missing the extra x. Multiply top and bottom by x. Our middle fraction had the single x. It was missing the x plus 2. So we're going to multiply top and bottom by an x plus 2. And then our last fraction had the x plus 2. It's missing that single x. Multiply top and bottom by x. Simplifying, there's what we get. Eliminating the denominators, we're just left with the tops. And next up, we are going to simplify and get one of our sides equal to 0 because we've got a quadratic. Combining like terms. And then we're going to add the x squared over to be with the other terms on the left. Here's our result. Because we've got a quadratic, we are going to factor. So the two numbers that multiply to 6 and add to 5 are 2 and 3. And the two solutions that we end up with are x equals -2 and x equals -3. Now, when we plug those back in to check, we actually get an extraneous solution. X equals -2 will not work. All right. So since that one does not work, it's extraneous. You don't need to include it as a solution. But x equals -3 does work. So that is our only valid solution for this rational equation. All right, that is it for today. So your homework for 4.5, just for now, try problems 1, 2, 5, and 6 in the top half of your homework. And we'll pick up tomorrow with the rest of our rational equations, a couple more examples, and we'll look at rational inequalities as well. All right, hope you guys have a great rest of your day, and I will see you tomorrow.